when you look at the picture. Therefore, it is important that an unbroken chain of comparisons is developed as far as practical, keeping in mind the degree of uncertainty of measurement that increases as the chain goes down. The degree of uncertainty must be mentioned on any calibrator or calibration certificate, depending on which the laboratory can decide the acceptability. This unbroken chain of comparisons is called the traceability. I hope that concept is clear. Going back to the picture, you see that the chain of comparisons starting from the SI primary standards, going to the secondary standards, through reference standards and working standards to the measuring instruments. If you look at the right side, you see this arrow going up, which is the traceability of the material or mechanism that you are using for your comparison. And if you look at the arrow that's coming down here, that is the dissemination of the standard. So the traceability goes upwards, dissemination comes downwards. If you look at the left side, there's another arrow coming down, and that is your degree of uncertainty. And you can see that as the dissemination of the standard comes down, the degree of uncertainty increases. If the uncertainty is very small at the initial phase, the uncertainty increases to a much more substantial amount of degree as it reaches the testing or the measuring instruments. However, there are limits to the degree of uncertainty which is acceptable, and that's what I said about the uncertainty must be mentioned on any calibrator, and you can decide if this calibrator is okay for your laboratory. In India, the traceability of NPL and is evidenced by the certificate of accreditation to ISO 17025, and we'll talk about this again in later sections. The reference material you use in your lab or those with which your external agencies calibrate your equipment need to demonstrate this kind of traceability to ISO 17025. That is generally given in your calibration certificate. We'll show you an example later. To reiterate, as you see here, there is a dissemination of material in a traceable way, but with a certain level of increasing uncertainty. That was just a reiteration of what I said earlier. I hope that concept is fairly clear to you. Once again, since a new concept, I would like to reiterate with another illustration. Traceability is an unbroken chain of comparisons. Look at the links in this chain, in which every instrument in the chain is calibrated against a more accurate instrument immediately above it in the chain. Remember the picture from before? Calibration thus is the linking of measurement standards and or measuring instruments to relevant national or international standards through an unbroken chain of comparisons. Again, to reiterate, national traceability is to the National Meteorology Institute or Laboratory, NPL, New Delhi, and the international to the SI system of units in BIPM, France. After traceability, the second concept that requires mention in the case of calibration is the uncertainty of measurement, something that we need to understand in detail. Every measurement is subject to some uncertainty, even the SI units. A certain amount of variability is observed in repeat measurements results even if the measurement system is perfect. This is an inherent characteristic of a repeat measurement, and this can be due to the measuring system, analyte being measured, the environmental factors, the operator variance, or other sources. A measurement result is only complete when accompanied by the statement of uncertainty in that measurement. We talked about this earlier also. The measurement result should therefore be specified as x plus or minus u, where x is the best estimate of the measurand and is equal to the average of repeated observations. U is the uncertainty of measurement. The use of good laboratory practices such as traceable calibrations, careful calculation, good record keeping, and checking can reduce measurement uncertainties. So, I hope the concept of traceability and uncertainty are clear for you now. And so now we have to understand how do you calculate and compute and understand the amount of uncertainty of a calibrator or a calibrating system. And here I want to stop and tell you that something that I had said earlier also, there are analyte calibrations as well as equipment calibrations. Let's consider equipment calibration as a kind of coarse tuning of your equipment and your analyte calibration as a further fine tuning of your equipment. Okay, so I'm going to show you a calibrator insert for an analyte calibration. In this case, a hematology calibrator for a cell counting, and it's for a cell counter calibrates. It is called the traceability uncertainty of hematology calibrator is the what this product insert is titled. And if you look at this sheet, you will see there are multiple columns here. The first column is your names of your analytes, WBC, RBC, platelets, etc. And you move on to your fourth column, you see your target values. And if you move on to your next column, for your fifth column, you see the uncertainty of each component. So this is how the product insert comes, and this is a very important resource that you understand the uncertainty of each of these components. And if you move down, you see there is a ICSH, which is your traceability. So this kind of a product insert is very important. This is an information sheet or a reference sheet or whatever you would want to call it. And it's a very important resource that you have to document and keep filed, and also along with the expiry date and lot number, all these things will be mentioned on your product insert, and this should be looked through, understood, and also filed. And all these components should be understood before you embark upon the calibration. If there is an uncertainty which is beyond the acceptability of your laboratory, you can always refuse to use this kind of a calibrator. So, second resource that we have here is a calibration certificate. It's another very important piece of documentation in the event of calibration of equipment. After your calibration is done, the agency which is calibrating will issue a calibration certificate with traceability and all details required to understand and evidence your calibration, with the details of your uncertainty, your traceability, and other very valuable inputs in your certificate. This is a reiteration. The result from calibration or a measuring equipment or measurement standard is given in a calibration certificate or a calibration report. It can be either in a hard copy or an electronic format and should include a minimum of these things: name and address of the calibrating agency, unique identification certificate, name and address of the client, the identification of the equipment calibrated and by the manufacturer or the brand and type, and the unique identification number, date the calibration was performed, the environmental conditions during calibration, standards used with their validities, calibration uncertainty, traceability. Very important point. Whatever standard, so that they are telling you, I'm calibrating your equipment, this is how much uncertainty my standards or my calibrator is having. So that uncertainty and traceability is also stated. And moving on to identification of the method used. Calibration results obtained and units of measurement, including a record of the readings obtained during calibration for each of the calibration values, and record of the calculation of the accuracy and precision of all sets of values, any use limitations of the equipment calibrated, any correction factor, the uncertainty of measurement of results. This uncertainty here depicts the uncertainty your equipment has. Okay, I hope you are understanding it from the uncertainty that is specified earlier. That was the uncertainty of the standards. And now they are saying after calibrating, this is how much your equipment is having the uncertainty. Coverage factor or confidence limits of each level, validity of the latest calibration and when the next calibration is due. So these are the components that generally are given on a calibration certificate. Now we have the authority under which the certificate is issued. In this case, there is an NABL symbol since the calibrating agency is NABL accredited. NABL accreditation here means accreditation to the standard 17025 that we have talked about in the earlier discussion. I hope you understand the components that should be checked out on calibration certificates, and all these different things at the degree of uncertainty, the traceability and all other things should be verified by the laboratory before accepting the certificate and accepting the equipment back after calibration. And also one thing that we had already talked about is the operating ranges. Suppose your pipette is being used to measure 100 microliter volume, and that is the only requirement you must be having in your laboratory. And so that is where your attention should be. Your pipette may be able to measure up to 1000 microliters, but that is not in your area of operation. But your 100 is very important for you. And that's where you would exactly look to see how much of uncertainty is there at this 100 microliter level. Or suppose you're looking at a thermometer that you're using to measure a fridge temperature, which is to be between 2 to 8 degrees or minus 20 or minus 80, whatever it is. But please make sure that when it's getting calibrated, these operational temperatures are calibrated. And what is the uncertainty there? That the thermometer may be able to measure up to 100 degrees or 60 or 70 or whatever, but it's not relevant for you. Your fridge thermometer has to measure and be very sure of the uncertainty between 2 to 8 degrees. Similarly, for a water bath, your 37 degrees centigrade is important. So that is how you decide what your operational requirements are and what is the uncertainty there. Calibration of equipment can be outsourced. That's another thing that I would like to bring to your attention, to an external accredited calibration laboratory, or this can be done in-house also. Mostly, generally in India as of now, it is getting outsourced, but it can be done in-house also. We have already talked about the outsourcing of calibration to calibration laboratories. We are mostly talking about minor equipment, ancillary equipment like pipettes, centrifuges, etc.
Calibration of equipment is required for both analytical equipment as well as ancillary equipment. The ancillary equipment like pipettes, centrifuges, etc. can be calibrated in-house or can be outsourced to a third party or a second party agency. We will talk about in-house calibrations in the next slide, but before moving on to that, we need to understand something about the concept of verification of calibration. This is what happens in most analytical equipment like your biochemistry analyzers, etc. A lot of your components like the lamp, cuvette, etc. are checked through the mechanism of just checking it. And because at this point, there are certain calibrations which cannot strictly be made in the SI units, in these cases, the laboratory is required to use some alternative mechanism